So you just watched a video on separable differential equations, and now I'm going to show you how to solve them with a particular solution. So this is Chapter 7, continuation of Lesson 1. So here's the first example. So what I want you to do as you're watching this video is start at the very top by yourself and see if you can solve it. Don't peek at my solution work. See what you can do by yourself. And then come back here and check to make sure your work is correct. So for this one, this actually does not have a particular solution. This just goes through the process one more time for you. You have dy over dx equals 2x times 1 plus y squared times e to the x squared. So if you remember correctly from the previous video, you want to move all your x's to one side and all your y's to the other. So when you do that, you get the integral of 1 over 1 plus y squared dy, and that equals the integral of 2x e to the x squared dx. Now to solve the left side, if you look at it carefully, you can see that's arctangent. So arctangent equals that right side, and for the right side, you're going to use u substitution to solve. And when you do that, you get e to the u. Not bad, right? So you put u back in, and you have that inverse tan, or arctan of y, equals e to the x squared plus c. Now to get y by itself, you are going to bring it to the other side, and it'll be, if you remember inverses at all, your angle, or y, will equal tangent of e to the x squared plus c. So hopefully you got that one correct. I think this was just a little note for practice. All right, let's try with a particular solution now. So this is our second example. We have dy over dt equals cosine of 2t, and we're given that y of 0 equals 1. So again, you're going to do the same process. Try this on your own first and get all the way to the end. All right, so if you've tried it on your own, you have the integral of 1 dy equals the integral of cosine 2t dt. Now, 1, you know the antiderivative of 1. That's not bad. It's just going to be y because you're in terms of dy. And for cosine 2t dt, again, you're going to use u substitution. So what an excellent review for this. So you get 1/2 sine 2t plus c. Now, when you're given a particular solution, you are going to put those values in. So what that means is y of t equals 1. So when t equals 0, your function equals 1. So go ahead and replace t with 0. So you get 2 times 0, which is 0, and sine of 0 is 0. So this whole part, 1/2 times 0, all goes away to equal 0. So you get that c is 1. And then, of course, you're going to replace it in your final answer and have 1/2 sine 2t plus 1. One last example. I want you to go ahead and try this one on your own. You have dy over dx equals 5xy. Doesn't look that bad, right? But you're given the particular solution of 0, -1. So when you solve this, remember to bring your y's to one side and your x's to the other. So a whole lot of algebra, and you get the integral of y, well, that's just y squared over 2. Remember, you don't have to add your c here because you only need c once. And then on the the right-hand side, you have the integral of 5x dx. Well, that's 5x squared over 2 plus c. So now you have to solve for c. You can solve for c at any time, but you're better off just solving for it here, and you'll do all this work out and get that c equals 1. So once you have what y equals, you can go ahead and put your c back in. Now this is y squared, so you are going to have a plus and minus branch of the square root of 5x squared plus 1. You need to think about your particular solution here. This is really important. You have the point 0, -1. If you were to graph this square root function, your positive branch will be above the x-axis, and your negative branch is going to be below. Now, this isn't the exact graph. It's just a quick sketch of what a square root graph looks like. But the point is that 0, -1 is going to be below the x-axis. So your answer is going to be the negative branch. So make sure that you check to see where your solution belongs and don't leave your answer as plus or minus. You need to have it just negative if it's the negative branch and just positive if it's the positive branch. All right, I'm going to give you a few try this problems to work on in class, and I will see you soon. Bye.